Oh.
Aren't you gonna load a look?
Yeah, I'm a little late. When just go.
All right. Hi, this is John Crook.
I'm Adam Crook, his brother, his assistant.
Yeah, we're doing problem number 9 for my second project. Sorry.
Okay.
Okay, we're doing the wedge at problem 9. Revisit the problem of the cutting wedge of cheese into 2 equal proportions. This is straight across, not in half.
Not in half.
This is sort of a different way of doing this problem.
Oh.
It's sort of the long way, but it's basically the same kind of principle.
Same. Okay.
Okay. In that lesson, we found a solution for a 90-degree wedge of cheese. We're going to do 60 degrees. Find the solution. Our first is find the solution doing for 60 degrees, basically. Okay? Alright. How we do this is we got to know the circumference and area of a wedge. And it's...
Alright, well, first of all, give me a formula so I can... Alright, circumference...
is 2 times pi times r.
2 pi. I don't have a pi symbol, so I'll just say pi. R, we'll just go with
That's
that.
3.14.
Yeah. Well,
just do 3.14.
Alright.
Times r.
R. I'll just say R there, that's fine.
Equals r times d, which is radius and diameter.
Equals RD.
Yeah. Also, we need area of a triangle, which is 1/2 times base times height.
Alright, so area triangle. I know what area triangle is.
Yeah, we need to know that.
1/2 equals 1/2 BH. There we go.
Yeah. That got everything there?
Yeah, got it. Yeah.
Alright. Basically, we're trying to find the area of a 60-degree triangle. I've already found the area of a 90-degree triangle, which is a quarter. Right. 60 degrees is about what? How much of a triangle? About 2/3?
2/3, yeah.
Yeah, so it's 2/3, so it's like... Yeah, 0.66 something.
So 0.667. So what are we gonna do? So 60 degree.
Yeah.
So are we gonna have like a? So what are the angles are we actually looking for?
60-degree angle first.
60 degree. Well, what are the other ones? Since we have to graph it, do we have to graph it?
What is the solution for a thin wedge as it approaches 0 degrees?
All right.
Because we got to find one that's as it approach. We got to find a decreasing one nearing 0.
I'll go 59 and 58 and 57.
And we got to find one that's about 359 degrees because we got to leave at least 1 degree blank. And we got to find one that's 180 degrees and 270. That's about it.
All right, so we'll just let that fill in.
Yeah.
And then we'll put 180 and then 360 or 359.
359.
359.
Gotta leave that small slither.
I
I did a lot of this already, so.
Okay. All right, so
you got 270 in there.
Oh, 270.
Yeah, we gotta find 270.
270.
But I already found what 90 degree is, basically.
Okay. So all right, so if this was 180, would it be like twice that, or?
It'll be. That's about half. That's 1/2.
Yeah, I know. So 90, but 180 is twice 90.
Yeah, it's half. The 90 degrees is 1/4. Adam.
Oh, okay. Never mind. I got you. I know where you're going with that one. Duh.
Yeah.
It didn't ring and register in my mind that actually you was saying 1/2, 1/4.
You're doing like a circle.
Okay, I got you.
270 is about what?
3/4. Okay,
Yeah.
now I see where you're going with that one now. All right.
You see what this is? It's a lot of the work I've already done for 90.
Well,
Just got to expand it on it a little bit.
All right, so since it's gonna be.
You mind turning off your internet?
Well, I am sorry, but it's like, I'll do that. I'll
disconnect.
All right, back to it here. All right, so this would be.
We gotta have, okay, for like 180, you gotta have, for 359, let's just do that. You gotta like have 1/360.
Yeah.
Because you gotta divide that.
All right, so
1/360.
Yeah, so
that's 359 people. Okay,
right.
For 180, it's 1/. It's practically 1/2. That's 3/4.
That, of course, it did dates instead of numbers.
Yeah.
Format cells. We want
fraction.
Let's just do fraction. Yeah, there we go. I don't know why I did that. 1/2. There.
Yeah.
All right.
Okay, and 3/4.
Then 3, 4. See, it did it again.
You gotta format each one.
Format each cell. All right, let's just do this right. Format cells. Fractions. Thank you.
Yeah.
All right, so 3/4.
Yeah.
And that's
160. Yeah, you got.
I'll just redo it again so it reckon. See,
it just loves you, doesn't it?
Oh, it's loving me. Oh my. Fraction. Yeah. Well, I want up to 3 digits. Yeah. Thank you. All right. Thank you.
Okay. Basically, this is the formula you gotta use. Except for quarter, you put half circle.
Yeah.
I would replace that with half circle. So basically, you take. Okay, let's do 180.
180.
No, do you have 60 degrees already?
No, I don't.
Okay, that would be 1/3, wouldn't that be?
That'd be 1/3.
Yeah, 1/3.
So I need to format the cell, so that would be.
Okay, I gotta do it. All right. I'm gonna have to convert this stuff so I know it.
Yeah, I would say
so.
I would need an equation. Give me an equation.
Okay, it'll be 0.33. So we don't have.
6. Oh, right. So
we're doing 60.
333.
Yeah. Okay, that's repeating. Times 3.14.
All right. I'm gonna let's do it like this. I need to format this so I can get the right. Here, we'll do 60 degrees is 1/3, so 1. Trying to think. How should I do that? Well, give me a decimal of each one. Yeah, this one's gonna be kind of tough because 60 degrees is
0.33.
Yeah, I know. I'm trying to figure out how to if I can create a graph or something like that to help me, but whatever.
We're not to that point yet. Okay. Okay, and R is basically the length. Is the length of the entire wedge. And we need. He doesn't give that, does he? Just put in R. Times R.
Yeah, well, that's good, but.
Yeah, I know. So we gotta figure out what R is. Alright, Alright, then we go on the other side. It's pi times h to the second. If I'm not... Does this make sense to you?
Well, they're not. Well, I need something from your assignment so I know what to do. So I mean.
Yeah, I know. I'm just trying to remember how we did this. Because we got to solve for r. I know that. Okay. Okay. Because h for a quarter circle is h for a quarter circle is 1.77. Because h equals 1.33. That's the height of a quarter circle. Okay?
Alright.
Okay. And we take, it was r. R's...
There we go. That's much better. That's the
I'm going to assume r is about 3 inches. I'm just using that as a base number, okay? So r is 3.
You're going to say R is 3.
Yeah, I'm just basing it off using this, okay?
Right.
R is 3.
Alright, so what I did here is I put, that's the degrees divided by 360, and then took times pi times r.
Yeah.
So that's what I did.
I'm just using the variables from the lesson we did a few weeks ago.
I'm guessing that's what they're going to go off from. So
yeah, that's what I'm assuming. So I'm just basing it off this. So.
All right, so I'm going to go ahead and fill this down since I got the formula.
Yeah.
So there we go.
Okay. We just solved for 60, right?
Yeah, that's solved for 60.
All right, now let's go to 180 because we got to do. What's this? No, we're doing 1 degree, 1 over 360.
Well, that's fine because I can just bring this formula down.
Yeah, I think we got it now. I'm just using this stuff that I did in class as the basis. So.
All right, so let's bring this down. There we go.
And that's through 359.
Yep, 359 right there.
Okay.
Because that's 359 over 360 times pi times 3.
All right. So we got the formula for that. Now we got to... All right, we just did through 359. What about a wedge angle that approaches 360? So it'll be 359 over 360.
Yeah, that's what it is.
Okay.
Because I set up the equation right here.
Okay, we did one up.
We did 180. We did 270. Right there.
Okay.
And that there is 359 right there.
And we did 1 over 360, right?
Let's see, 1 degree.
Yeah.
Right here, 0.2616667.
Okay. So we got all that.
Yeah, so this is the degree angles here.
You see where I'm going with this, right?
Yeah, I see. The 60 degrees is right there.
Yeah.
So I took that divided by 360.
Yeah.
And then multiplied by 3.14 times 3.
Yeah.
So it went all the way down to 1 degree right down here.
Okay, as long as
I got it down to 0 here. So.
Okay, as long as you got the other ones now.
Yeah.
Okay.
Yeah, that's done.
Now we got to create a graph.
All right.
Of the cutting location as a function of the wedge angle. So we got to create a graph.
So from 60 degrees?
No, 0 through 360.
Oh, so they got.
So we got to do it through all.
Okay, fine. All right. Well, we're just gonna have to do it like this then. 360
Sorry, people. I'm still getting over a cold.
359. Yeah, thanks, bro. I mean, you're really helpful. All right, so we have to actually go through all the numbers here.
Every single one of them.
Oh, gosh.
This was probably easier than the last one we tried.
I guess so.
Hey, at least we got this to copy
All right,
from.
so we're going to go from 0 to 360.
Yeah.
And we got to copy the formula.
Basically.
So this is the formula. I'm going to go ahead and copy this. Now I'll just have to redo the
formula a little bit.
No. Paste. No, paste. I want you to paste.
Big butthole.
No, because I want this cell reference to go right here.
Yeah.
E9.
Yeah.
And then it will accept that. All right.
Now we got to do it for all of them.
Yeah. I'm going to bring that down.
Now.
And then we'll just...
Jeez, that's small.
Yep.
Starts getting small. Go back down a little bit. Closer you get to... Jeez, that is very small. It's got getting less than 1. You're getting to millions.
Yeah, it gets less than 0.1 right here. What's the 3 meters or something like that they give, or inches?
Inches.
Yeah, so this is all inches. This is all lengths in inches right over here.
Yeah, that's less than millimeters.
This is the degrees out of 360.
So we get less than an inch starting where?
Starting at
38 degrees, less than 39 degrees.
Less than 39 degrees, we get less than 1 inch.
That's hardly fills. That's smaller than a mozzarella stick.
Yeah.
Or
Alright.
the thinnest piece of string cheese you ever had.
Something like that, or whatever.
I think string cheese is better.
But we're going to...
Now we got to create the graph.
Alright, so graph all of this. Insert
graph.
Any particular one? Line graph? Bar graph?
Line graph will be fine. And we could throw in a scatter plot. That would be even better.
Well, here, let's do one.
Well, let's do the scatter plot. First one. No, we don't want lines. The first one. Sorry.
Hold on a minute.
Scatter plot. We want that one.
Scatter?
Yeah.
Yeah, this is... I would assume this is the...
We don't want line there. That's the line graph.
Yeah, I know, that's scatter, though.
Jeez.
Yeah, because the relationship is that because all these are fractions.
Yeah, and this is I'm guessing this is consistent. It's like a linear drop.
Because of course 0 is 0.
Well, yeah, because you're dividing it by the same amount every time, aren't you?
Yeah.
Subtracting.
Because this is out of 360 times, and then
you're working your way back.
I wonder if I should just. Well, I can't really flip the axis.
Why don't you just make the graph a little bit bigger?
Yeah, I'll do that.
So we can see a little bit. Jeez, because all of the will be concentrated.
Yeah, because this is the inches right here.
Yeah. Can you create like the T shape, like that big plus graph, line graph? You know where it goes into the negatives.
Well, when it comes to circles, you don't have negatives.
Yeah, well.
No, yeah, because it's like... in a circle, you don't have negative numbers.
So basically, you're just rolling it backwards.
Yeah, let's see here.
Leave that graph up there.
Insert line. Let's go back. Stack line.
What would be... No, not that one.
Well,
that
one will probably be the best one because because here's this.
It gets real close the further in you go.
Yeah.
Because series 1 is the degrees, right?
Well, the x-axis is the degrees.
Okay.
The y-axis,
Y-axis.
Actually, that doesn't make sense though, because that.
No.
I don't think that's a good one.
No.
Yeah, I don't think that one was a good one. Format. I'm trying to think what will be good. Format selection.
No. Get rid of that graph and start over.
All right, try that again.
Yeah,
right.
Let's try that again. Okay.
All right.
Because we can't exactly tell what's going on.
Yeah. We should be going no higher than 10.
Yeah.
And I think what we had that other line was like.
Okay, insert graph.
Recommended charts. Let's see what they give.
No, we don't want bar.
No bar.
No, that wouldn't. What the hell is that?
That's a paratro distribution of data. I don't know.
No, we don't want bar.
Histogram. No. I think this is the best one we're gonna have.
Yeah, I think so, because that's close. I think that's the best we're gonna get.
Yeah.
Because whenever when you get below down here, you're getting into really small, very small numbers.
Yeah.
So I think this is the best we can do. Because you're basically decreasing at a steady rate, but at the same time, when you get below, it's 39.
Yeah, when we went below 39 degrees, which is...
It got so low that if this was a scatter plot, it would be concentrated very heavily in that area.
Down there, that would be a scatter plot would be...
But I think that's the best we're going to get.
Yeah, because everything above it is, when we got...
Is at least whole number.
Whole numbers. Because it didn't get to 2 until 77 degrees.
And it got lower and lower below that.
And then when it got to 3, it was 115.
Yeah, I think that graph's the best we're going to get it.
Then 153 at 4. 192 at 5.
Kind of makes your head spin.
230 at 6 inches.
You think we're going to need an electron microscope to see this?
I don't think so. And then at
267, 68, we're at 7.
And then 8. Yeah, this is...
Jeez.
Yeah, we're 8 at 306.
Yeah, that's the best we're going to do.
I think that's the best, when we get to 9 here.
I'm at 344,
so we're almost filling in the circle.
Yeah, show that graph again.
Yeah.
Yeah, I don't think we can do any better with this graph. Because they're all...
Yeah, it's just...
It's decreasing so small that you can't see every single one.
Yeah.
I think that's the best we're going to be able to do with this
so
one.
This is the formula. It's what we came up with. It's...
Well, more or less I did.
Or you did, yeah. So we got E9...
With my teacher's help.
E9 divided by 360 times pi times this... I would assume that's the diameter.
Yeah.
So, yeah. So
I don't think we can do any better.
Alright.
Well, this has been John Crook, and I want to thank everybody for your attention.
I'm Adam Crook, his assistant.
Oh, yeah. Okay, never mind. I don't want to get started with that.
Alright, see you guys later.
Thank you.